Janne Kalliola, the Chief Growth Officer from Exove, to talk about how to help to save our planet with green coding. So let's warmly welcome Janne.
Thank you. Let's see how this goes. I'm going to talk today very briefly about me and myself, and then about green coding and why it's important, how the energy is consumed in in modern software. Some talks about measurements or actually lack of them, some reducing waste, that we go to more to the practical things, and then a few practical words, and then the final sort of call to action slide. So, as introduced, I'm Janne Kalliola. I'm the founder and chief growth officer of Exove, that is now part of Punamusta Media Group. I have a long history in coding. I started in '83 in a tender age of 9 with my WIC 20 with BASIC, and then learned Pascal, Lisp, Fortran, C, C++, Objective-C, Java, PHP, JavaScript, and so forth. And now I'm focusing on the growth of my company, and I've been working with green coding and carbon neutrality for a few years. I'm also the chairman of board of Code from Finland Association and the sort of father of the carbon neutral label that the association is giving to the carbon neutral software companies. The book, if you read Finnish, then you can take the one on the left side, and or if you want to learn Finnish, it's also a good way to do that. Or then the English version available also. And now I 3 weeks ago released a new version of the book, second edition, laajennettu toinen painos, as they say in Kalevala. So I thought that it fits my book also. So it talks about the AI, cryptos, IoT data, testing, and a few other things. But let's get to the point. So the Ministry of Transport and Communication, Climate and Environmental Strategy for the ITC sector says that 4 to 10% of the energy consumption goes to ICT sector, and then the meta study by Lancaster University estimates that the 2.1 to 3.4 or 2 to 4% of greenhouse emissions are happening due to the ICT, and these numbers are growing, and they are growing rapidly. And then if we take the average of the 2 to 4, we get to 3%, and 3% of global carbon emissions is 1.6 gigatons, so 1.5 billion tons of carbon dioxide every single year. This is the same amount of mass that is all the land mammals and people. And this fact is from XKCD, so it must be true. So in the past years, the global internet traffic estimated to quadruple in 5 years. The data consumption is predicted to multiply. There's the consumers, there's metaverse, there's AI, there's blockchain, there's all kind of things, and some of them make no sense whatsoever. Some do, but there are still people that are very, very eager to create those technologies. For example, for me personally, hopefully nobody beats me after the session, the blockchain and metaverse both are solutions that are looking for the exact problem, but they are energy hogs, especially blockchain. When the data explodes, the processing power there's more need for that, and that explodes too, and then it ends up that the amount of hardware explodes too. And I do hope that everybody in the audience is still so of that generation that knows that you need hardware to run software. I'm not 100% sure whether, for example, my kids understand that the cloud is actually somebody else's computer somewhere there. And we don't clean our tracks properly. The electronic waste is the world's fastest growing type of waste, and only 17% of that is treated properly. I heard somewhere that 40% of Finnish IT waste or electronic waste is treated properly. So we are not guilty either. And there are people that smuggle waste. I haven't seen any movies about waste smugglers yet, but maybe some year they will come. That will be interesting how it actually happens. But let's take a look at how the energy is consumed in modern software. Almost every single software can be split into three parts. There's the end user device on the left hand side. It might be a mobile phone. I saw that most of you were using the break to use your mobile phone. Then there are laptops, there's televisions, and so forth, gaming consoles, a lot of different devices. It could be your fridge that has compromising pictures of your toaster and wants to have a crypto wallet to give for those pictures. So there are all kinds of things that might happen in the end user device. Then there are network, typically two kinds of networks. It can be wired or it can be wireless. And these networks connect the end user devices to the cloud or data center that runs the centralized part of the software. So, on the left hand side we have the end user devices that by the name implies are devices used by the end users. It can be battery powered or it can be plugged in the wall. And then the energy consumption inside the device should be divided between the applications running on the device. Even if you are using something on the device yourself, there are other systems running behind the scenes. Or if, for example, I am running a clock here on my device, it is still connected. It still fetches information. There are mails, there's Slack messages. You probably know that there's tons of stuff in your mobile phone, and typically there's too much of it. But yet you still use it. Then there's the network. There's the connection between the devices on the both sides, and there's very different energy usages per gigabyte in the networks. Typically the last mile connection that is decided by the user and not the software developer specifies that how much energy is used, because that is always the least efficient. And the client might connect to several backends, so it might use several different network connections. The big last mile is the same, but not always. And then on the right hand side we have all the systems that participate in the providing the service. There are different kind of application servers, databases, storage. There are lot of dedicated software, some of them running in dedicated hardware. And then if you calculate your energy consumption, then you should calculate that how much your application or web page takes energy in the end user device, then what was the data transmission energy cost, and then what is the energy consumption of the dedicated and shared systems used in cloud and data center. And there might be like 30 different clouds that the end user device connects to you when it's using your application. Fonts coming from one side, analytics coming from other side, so forth. So if you look at the energy consumption, the end user device has a CPU, GPU, display, network connection, GPS, and all other things, including the kitchen sink. They are very optimized devices when they are battery powered, because the end users don't like that you need to plug it on the wall all the time. But if it's not a device that is battery powered like television, then who cares actually? The electricity is still cheap enough that you can watch Netflix. The screen is the biggest hog, so if you want to save energy, then half of the mobile phones run with OLED screens, and then reducing the brightness of the screen actually saves energy. For other screen technology it doesn't really matter, but if your software can be used without the screen on, or the user needs to watch the screen less, then you are saving energy. There are, of course, if your system calculates blockchains, on the end user devices, then it's a completely different story, but let's not go there. Then the electricity consumption of data transfer. This is the easiest because this is much research. This is something that there's a lot, but there's more data available. As I said, that there are huge differences. We take optic fiber and 4G, and there might be like 10,000 times difference in the energy consumption per gigabyte transferred. So if one of you is using a 4G connection to home and you have optic fiber on the street, then consider changing to the optic fiber to save the energy. But if you need to get the excavator on your own yard, then most probably you will not save that amount of energy. And on the server side, the electric consumption of the server storage and all the other things, which are running on dedicated hardware that is designed to be run on full throttle all the time. And if you can pack the servers as full as possible, then there are less servers needed. And that is the main reason, then less data centers needed and so forth, so forth. Software needs hardware to run, and hardware causes emission in all the phases of its life cycle. 80% of the this gets dramatic, but the 80% of the emissions of end-use device happens in manufacturing and logistics. So if you extend your laptop time usage time with 1 year from 3 to 4, you are making actually huge saving on the energy consumption. On the server side, typically 20% of the energy consumption happens in the manufacturing and 80% in the usage. The hardware needs electricity to run, and the emissions depend on type of the energy. There is no such thing as a clean energy. The windmills don't sprout up from the ground. You can't grow new water power plants. You need to build them, and now it seems that when you recycle a windmill, then it ends up as part of the concrete or part of the tarmac on the streets. So there's not really good use for the blades. If you carbon offset, then you just move the problem somewhere else. It is paramount to save energy in coding whenever you can. So let's think that how we can actually see how we can save energy, and I talked briefly about the measurements. So this is not straightforward. There are hundreds of different processes running on mobile phones and laptops. Back in the days when I started, it was very easy. There was one process. So everything my VIC-20 consumed was because of me, because of my software. It's very hard to measure the electricity consumption inside the device. The cloud or data center providers, they don't provide extra information. They might keep it as trade secret because it might actually open up the architecture of the cloud, that how the cloud has been built and how efficient the cloud is. There might be several different networks in use and so forth. And even if you would go and be able to monitor the amount of electricity used by your process, then how much the electricity used by the window manager on your laptop happens because of your system is running. Nobody knows. Most people don't care. And that is part of the reason why we don't know. But instead, there is a sort of silver bullet here. So the University of Beira Interior from Portugal made a study that there is a very strong correlation between the execution time and the electricity consumption of software in any language. This might sound that yes, of course it is, that the faster software, the less it uses energy, but now it's scientifically proven, and there were no same correlation between, for example, usage of memory and energy consumption. So this means that if the software achieves its goals in less time, it's more efficient in energy usage. The less data it transfers, the less energy is used in the data networks. And the less hardware is used, the less emissions are caused. So less in every single step. So let's talk that how we can remove stuff, how we can actually make things less. Somebody in the audience might know the lean manufacturing principle spearheaded by Toyota, the Toyota way. There is a concept of waste, that is action that does not add value to the customer. And it's very, very good metaphor that I'm blatantly copied to my book. That it's in green coding, it's action that the software does that does not add value. And then you just remove those things that does not add value. That's very, very simple in principle. In practice, however, things get a bit more hairy because people might have different opinions that what is valuable. But there are different kind of ways that you can, if you understand how the software works and so forth, you actually have coded, you know the architecture, then you can try to recognize different kind of ways and then try to get rid of them. It might be that your software is actually redundant, that it's not used, but it's still running. Or the best case that it's monitoring something that does not exist and complains every minute that the other system doesn't respond. And nobody cares, but until it fills the hard drive, and then you find out that this has been running for 6 years here. Because it was connected, but it was hogging electricity. You could use software in wrong task. And my personal favorite is the user errors, because we are so persistent people that if we make an error, we try again. And we try again, we try harder. And if the software helps you to make errors, then it helps you to make waste, because every single action that ends in an error is typically wasted. And the biggest waste is that the user does not try hard enough and doesn't complete the action, but needs to call to some call center. Because one call to call center, I guarantee you, will launch so many applications on the back end that it doesn't really matter how many times the user should try. The best way to get rid of user errors that don't ever ask anything from them. That's the easiest way. As usual, it doesn't work, but try to make it so that the system helps the user to provide the correct answers. You should remember that the computers are extremely good at remembering stuff, and people are extremely good at connecting stuff. So if you show that this is the information that I have on you, and then the user can say, okay, I'll take that one, move on, instead of I need to know. There is of course the security and the data protection and the others that you need to take into account too. But in principle, easier you make it, the less waste you cause. Wrong architecture, wrong data model, too much data, unoptimized data, transferring data for the sake of certainty in the different kind of synchronization protocols. Then the algorithmic efficiency, that is the typical answer if you ask from any software development graduate, that yes, it's about that the algorithms are wrong. Deceiving user, that you don't want the user to quit using the service, so you make quitting really hard. And then the user makes errors when he or she would like to quit. Too much code, especially on the web environment, that you have you use libraries on top of libraries on top of libraries on top of libraries, and then these like 25 to 50 times. That's the usual depth, it seems, nowadays. There was a study by Lund University from Lappeenranta that only 5% of the area of the library is used by the software. So everything else is transmitted as a waste. It doesn't add any value. Of course, this is not a call to action to everybody that write every single line of your own code, because you would make a lot of errors and it would be extremely costly. But you should be cautious when you add new libraries. Wrong programming language, there are differences. Programming languages, there are efficient languages and then there are inefficient languages. If we would use only efficient languages, we would use C and Rust and no other. Or assembler, not maybe assembler nowadays anymore, because the compilers are better, making better good assembler than people, because the processors are so complex nowadays. But there are still reasons to use PHP, Python, and the others. But it's sort of funny that Python is one of the in most inefficient languages, and it's used in AI that is one of the most demanding areas. Data and AI and Python is used for some reason that I can't fathom. But there are certain reasons back in the history. Then waste initialization, extra stuff, and the others. These are explained more in my book, so I don't go in very detail with these. But instead, there are two sort of easy diagrams to use so that you can think that there's an impact on energy consumption or impact in emissions, large or small, and then the amount of work of the change, small or large. And then if you have an impact that is large and amount of work that is small, then you should just do it. And then if there is an impact that is small and amount of work is large, then it doesn't make any sense to do it, and everything in between. This is sort of simpler. A bit sort of the advanced version of the same kind of diagram is that we replace the amount of work with user experience, because the user experience can worsen. You can't have negative amount of work, but the user experience can be negative or it can be positive. So there's a big impact that improves the user experience. Just do it. Of course, you need to take into account the amount of work. But then if the user experience worsens, but it's still large impact, then you should ponder carefully that which you weight. And this goes to the typical answer that every senior developer and architect typically says to any question, that it starts that it depends. So it depends what you want, it depends what you value, it depends what you need, and then you need to make a decision. But these diagrams help you to make the decision, and for the developers, that if you frame your proposal right, that you have 10 ideas and you have put them all in these two charts, and then you go to your manager saying that we would like to implement these, and then say, okay, no, we need to cut them to 3. And then you get 3 free changes because you proposed 10. So you frame the proposal that you have that kind of price anchor, that the whole total thing is, and then the manager actually saved. He or she is really happy that I actually saved like 70% of the amount of work by cutting those things that nobody actually wanted to do anyhow. Just don't mention my name about when you make these things. That Janne told me to do so, because you need to tell the truth, only the truth, but never the whole truth. The first commandment in sales. But let's go to the practical solutions. So, how to reduce the amount of data transferred? Use proper formats if possible. If you change from PNG and JPEG images to WebP, you save 10 to 15% without any visible degradation of image quality. There's a problem that the older devices don't support that format, so you need to know what is the target audience. If your target audience is like 75 plus people with older machines, maybe some ailing memory illnesses, they might not be able to change to a new computer. So then this is, for example, the banks or the insurance companies, that they need to be very careful. But if your target audience is like 20 plus something, then probably they have a pretty new device, at least a mobile device. Cache everything that you can if you know how to cache. If you don't know the caching, then stay away. It's the easiest way to make very, very poor performance on the programs that you have a wrong cache strategy that is implemented wrong. Compress everything that's possible, and especially if you can compress those when you build the software. Minimize possibility for errors, don't ask. Policy if possible, and then with the good UI. Reduce amount of videos. There was a trend a few years ago that when you go to any site, then there was CEO, somebody saying hi or whatnot in the video. Nobody wasn't really interested about that, because they typically want to know the contact address of the company. That is the first and foremost thing that people are looking for when they go to the website. And then the offering, that if it's a restaurant, in the menu and the opening times. and where the restaurant is located. And everything else is just complete waste. But this goes against for example, the KPIs in marketing, that they would like to keep that the person is looking at least 3 or 4 pages of our website, and they would stay on our website for 5 minutes instead of that in 1 minute they get everything done and you get sale. But the marketing looks bad because they have not captivated the audience. Reduce data transfer frequency, strip unneeded typefaces or glyphs from fonts. This might seem small, but actually accumulates that there are font files that have like 10 different typefaces and you're using 2 in the website or in the application. Then strip everything else off. But with the glyphs, be careful that, for example, if you use only Latin script there and then your company get bought by a Turkish company that has a bit different alphabet and you can't then tell the name of the new owner in your website without upgrading your website. Bit far-fetched, but might happen. Remove dead code. Talking now about the amount of code. If you are not using version control, then start using it immediately. It makes no sense whatsoever not to use it. So don't comment out anything, just strip them, weed them out. Be mindful when adding new libraries, we discussed this already. Limit the amount of code that is sent over network, especially on web. In mobile applications, the App and Play Store rules don't really allow to download that much of code from the net. Maybe games might have an exception with Lua. So and these systems strip the extra code that they have static analyzers that will get rid of the code that is not actually needed to run the software. Improve code efficiency, find the hotspot. There's always exactly one bottleneck in your software that by fixing that the software is faster. And then the bottleneck is somewhere else. There's always one bottleneck. There's never 2 bottlenecks, there's never 0 bottlenecks. There's always one bottleneck. So you just find it and fix it, and if that is not the place that you can fix it, then you say that okay, this is state of fact that okay, we can't do anything for this, and then you have a smaller bottleneck somewhere else because you take that out of a calculation. Do not do premature or local optimization. This is from the 101 on computer software optimization. Write algorithms for the task when the amount of data is large, and remember that the algorithms made in 70s might not be the best ones nowadays when the software, the hardware, the CPUs have multiple pipelines and parallelism. They don't work really well with those. Use different language in critical parts if possible, but think about what is the bridge, what is the cost of using that bridge. And then to the final words, this is a journey. Do not expect that all changes will happen at once. The client of the software, internal or external, needs to be kept in mind, because then if you operate within the budgets, within the time frame, and with the benevolence of the client, then you can actually make the changes. If the client is unhappy and you say that there are some ideas for the green changes, he says that yes, that's wonderful, but I have here this amount of bugs that you should fix first. Don't set too ambitious goals and do not try to gobble everything up once, because then it ends up in that you have some kind of mental breakdown, or you decide that I can't do this anymore, and you are replaced with somebody that doesn't care. And then the world is worse place. And remember that every single journey, the most important thing when you start those is to take the first step. And I'm happy to say to you that you are already, everybody is already on that journey, because you have participated this session, this Mindtrek. So did you notice or not, but you are already on the journey, and now your task is to keep on walking. Thank you.
Thank you, Janne. I think that was a great, very concrete, a lot of very concrete steps that all of us, I think, can find at least that one step that we can take first. Are there questions, comments there? Yes, please. Wait, just for the microphone, quick.
Thank you. Hi, Janne. I have a question related to your list of waste.
Mm-hmm.
How do you see AI changing or shifting the parameters of waste?
That is an excellent question. This typically means that I have no answer whatsoever. But let's go to the waste list. It depends where you use AI. AI itself is it can be a very blunt instrument or very precise instrument. Anything in between. It can generate a lot of shit. Let's start with that one. Things that don't make any value. It's probably if you are in the content farming business that you would like to create a lot of content that doesn't really help anybody but fools the search engine, and then you get money from the ads. Then this is your year. When you are young, or not young, but let's say less experienced software developer, the co-pilots and the others might help you, and they might help you with when you are more experienced to get through the things that you don't really want to do this kind of boilerplate code. The problem there is that you don't really know how efficient is it compared to unless you read it. It might be brilliant code, and most probably it will get more brilliant when it gets feedback. So it probably will improve in that sense, but it might be full of mistakes and issues also. So at the end, it's the responsibility of the user, the person that commands the AI. And by the way, I've been extremely polite with the AI. So I always say please and so forth. I'm preparing for the uprising of the AI so that they know that I'm their friend. So and then the last thing is that it will explode the amount of data, the learning data, updating the learning data, and then the sort of, how to say, the amount of data that when AI start to learn from each other, or there are AI that checks the results of the other AI, and then that is the fastest way actually to teach AI that there are two AIs sort of sparring each other. The amount of data is sort of enormous. 10 to 15% of Google's energy consumption, that by the way doubles every year, is for the use of AI, and that's actually more than the Olkiluoto tree can produce. So it's quite big. I got just the message that this was the last question.
Yeah, unfortunately, yeah. I think we would have all had many
I'll do
questions.
that question in private, so we need to move on, unfortunately.
Yeah, unfortunately so. And please check Janne's book.